Woohoo! All right, problem 4. This one has 4 parts to it. I'm not going to do all 4 parts. I'm going to do 2 parts. If you can do 2 parts, you can do the 4 parts. Okay, trust me, you can. Let's do 2 of these parts here. Okay, now that I went through that long video on galvanic cells, parts of them, the E reaction, all that stuff, how to use the chart, it should be a little quicker. The first one, A, here's A, written up here for us. It says, predict whether the following reactions would occur spontaneously in aqueous solutions at 25 degrees Celsius under standard conditions. Assume that the initial concentrations dissolve RL species in 1 molar solutions. Again, standard conditions. Meaning we're going to be using this chart, standard conditions chart, for reduction numbers to solve this problem. Okay, this is the way the reaction is written. It's written as calcium atom becomes calcium ion. Cadmium ion becomes cadmium atom. So would this happen this way? Would this produce, and the way you know that, the way this would be spontaneous is that word again, this would be spontaneous, see, he wants to know if it's spontaneous, that means would it occur in this direction? Would this reaction actually occur? If we had a galvanic cell involving calcium and cadmium, is this what would happen? Would this go in this direction? That's what spontaneous means. Remember, we've done it so many times now. Spontaneity means the way it's written is correct. Is it correct? How do we know? We know if we get a positive voltage or a positive E value out of this reaction. If the reaction gives me a positive E, spontaneous. Remember the last one we solved? Silver and aluminum gave me a positive value, a positive 2.46 volts. That is going to happen. That would be a reaction that takes place. I didn't write the reaction out, but we'll do enough reactions, we're going to write reactions out. So here's a reaction right now for us. Is it right? Okay, how do we know? So here's what we got. And actually, you could figure this out, whether or not this is written correctly, by using the chart and not doing any math. I'm not going to do that first. I'm going to do the math first. So let's see. What are the values here? We've got our values. What do we have? Calcium. Okay, calcium 2. Okay, so calcium, positive 2 is calcium, so I'm going to write this down the way it's written, calcium 2 positive, goes to the calcium and negative. My chart's really hard to read. It's all gray and nasty. 2.87. Okay, so calcium reducing, remember the reduction means a lowered oxidation number, gives me a reduction potential, a voltage potential of negative 2.87, which really means it's really down far on the chart. It doesn't want to reduce. It doesn't want to reduce at all. This means it doesn't want to reduce. That's what that negative means. It means it wants to oxidize. All right, what about the other one? What about cadmium? Cadmium. They make good candy around Easter. Cadmium. Okay, so cadmium becomes cadmium. Okay, now that number, hard to read. Negative 0.4. Negative 0.40. Okay, look them up yourselves. I think I got them right. Check them. Those are the numbers. So, what this says, let's go ahead and do the math on this. Let's set up our equation to find, under standard conditions, the voltage or energy produced by the galvanic cell, the battery. Remember, E at the cathode minus E at the anode. E at the cathode minus E at the anode. Let's look at the equation. In the equation, remember the cathode comes first. That's where the reduction happens. Who's being reduced? Who gets reduced? Whose number goes down? Cadmium. Positive 2 to 0. Positive 2 to 0. That one is undergoing reduction. That one, E at the cathode, gets written first. Its number gets written first. Cadmium's number gets written first. Okay, so cadmium's reduction potential gets written first. E at the cathode minus E at the anode. Okay, at the anode is, remember, A vowel, O vowel, their oxidation number goes in. That's where we put in at the anode is where oxidation occurs. So the oxidation, now let's see who's undergoing oxidation, just to verify. If you're undergoing oxidation, your number was up. 0, positive 2. That's oxidation. Oxidation number went up. So the calcium's undergoing oxidation according to this reaction. So we're going to take that value and put it right there. It says it's undergoing oxidation, so I take that number and I put it here. Now we do the math. Negative 0.4 plus 2.47. So the E of the cell, the voltage produced by the cell, that does come out to be a positive value, positive 2.47 volts. Is it spontaneous or not? Now, I think that's the question here. Determine predict whether or not it will occur spontaneously or not, okay? That's the question. The answer is yes. How do you know? Because of the positive value. We came out with a value for the voltage of being positive. That means that this reaction, that's spontaneous. Positive voltage means energy was released from the system, did not have to go into the system when it was released from the system. And remember, that does kind of have to go hand in hand with exothermic, negative, all that stuff does come back. I don't want to go into it right now, but it does. This does make sense. This is spontaneous. It gives off this potential, electrical potential energy to go and use it, be free, go fly, be free, do stuff. Make your cell phone work. So this is written correctly. Because it's positive, that's written correctly. All right. We could have determined whether or not it was written correctly much quicker. I just proved it with the math. You're getting a positive mathematical value out of it. We could have done it faster. Do it faster. Why'd you take me through that? Okay, how do we know that? If I find cadmium, cadmium is about here, and calcium's down here. Cadmium's higher, that means calcium wants to be reduced. Remember, this chart tells me if I'm comparing two different metals, who wants to be reduced and oxidized by their position. Higher up, reduced, lower down, oxidized. Cadmium is being reduced, it's higher up on the chart than the calcium. Is the cadmium being reduced? Yes, it is. Calcium is being oxidized, yes it is. So I can just look positionally and say that that is written correct. It's spontaneous. Okay, let's do one more. Like I said, if you can do actually do one of them, you can probably do the rest of them. I mean, if you want to shut me off now, go ahead, shut me down, shut me down. Let's do one more. And I'm sure many of you want to shut me down, all right. Get rid of this guy. Let's do, I don't know, let's do B. No, B looks boring. Let's do C. C, oh, C's got a couple of things in here. So C, let's do C. So 2 silver. And a silver atom plus the nickel ion. And we're going to get 2 silver ions and our nickel atom. Okay, is this spontaneous or not? We're going to show mathematically. Let's do the fast way first. The fast way first. And we're going to provide a mathematical solution to it. Because we should practice the mathematical solutions anyways. We're going to need them for the next couple of problems. So let's predict. This is showing silver going from 0 to a positive. What is that? Very good, Betty. That is oxidation. Okay, silver is being oxidized. Nickel goes from positive 2 to 0. That's a reduction. Would this reaction happen this way? Is this correctly written? Would nickel undergo oxidation, or nickel undergo reduction, and would silver undergo the oxidation? Look at the chart, find silver. Silver's kind of high up here. Silver's way up there. Nickel, if I had a nickel for every time, nickel is here. Silver, nickel. Silver, when in comparison to nickel, would not be oxidized. Silver's higher, it would be reduced. Nickel would be oxidized. This is showing nickel being reduced. Is that right? Nope. Just like Family Feud, you get the big fat X showing up on the screen. No. This would not happen this way. This is non-spontaneous. That's what that means. It wouldn't have this written wrong. If we reversed the arrow and wrote the arrow that way, showing nickel being oxidized and silver being reduced, that would be correct. That's spontaneous. It would go that way. But it's written like this, and so the question is this correct? The answer is no. We already know the answer, okay? let's not do the math. We already know the answer by looking at the chart and seeing who's higher. We can tell who gets reduced. Yeah, I know, but let's do the math anyways because we don't have to do the math in the next couple of problems. So let's do it. E of the cell equals E at the cathode minus E at the anode. Okay. E of the cell, E of the cathode. The cathode is where the cathode, not a vowel, R reduction, not a vowel, the reduction happens. So the reduction. So I'm looking for the thing that up here that gets reduced. Nickel gets reduced. It goes from 2 to 0. Nickel is getting reduced. So I'm going to take the nickel's value and put it in this spot for the cathode. Nickel's value, nickel, nickel, nickel. There you are. Read carefully, negative 0.25. So negative 0.25 gets put here because this equation said it got reduced, so I put it in the reduction spot. This equation says silver gets oxidized. Oxidized O vowel, A vowel, goes in the anode spot. So I find silver's value. Used it earlier, but I don't remember what it was. Positive 0.8. Positive 0.8. Do the math. So the E for the cell would come out to be negative 0.25 subtract 0.8. Negative 0.25 minus another 0.8, so that's a negative number, negative 1.05 volts. We would produce negative 1.5 volts. You can't produce negative volts. That would mean it would have, that's coming in, not going out. Going out is positive, spontaneous. That's energy going out. This means non-spontaneous. So that means that this would not be the way that this equation should be written because it wouldn't go in that direction. So it's a non-spontaneous reaction. We can get a negative. Okay. Reverse it. Spontaneous. If, in fact, if you reverse it, you would end up getting a positive 1.05 volts produced. All right. So the way it's written, not spontaneous. It's written backwards. Go ahead and do the other two. Check them. See if you can do those. Put the numbers in. I have faith in you. All right. That problem solved.